In this video, I'll be working through all the questions from the summer 2025 Cambridge A-Level Maths exam paper 3-1. It's going to be a long video. I do not want to just give you the solutions. I'm trying to teach you how to do these questions, and that takes time. We're not in the classroom, we are on YouTube, so take advantage of their tools. Use the chapters in the timeline to jump to the question you're interested in. And remember to pause and rewatch more difficult parts of questions. You can also change the speed you even watch the video at. With all that said, let's jump into question 1. In question 1, we're first asked to sketch a graph of this equation here. Y is equal to the absolute value of 2x minus 3. Now remember, sketch a graph just means a rough drawing. They want probably for a line, they want 2 points, all interesting points, I would say. So we can do this quite quickly. I'm going to go, hopefully if you can do it quite quickly, you can skip ahead, skip to the next question. But I'll try and go slow so you see what I'm thinking at different points. So a rough drawing, we'll just draw an XY axis. How you draw a line, because this is a line, y is equal to 2x minus 3, except it has an absolute value. How you do this is, I want you to ignore the absolute value. I want you to try and sketch this just line first of all. So how do we do it? A couple of different ways. You can put in x equals 0, y equals 0, get the points on the x and y axis. X equals 0, y is equal to minus 3. And that's the y-intercept. So we could have also just got that because when it's y equals, the y-intercept is there. Next you could put y is equal 0. Rearrange the equation, we get 2x is equal, let me write here, 2x is equal 3, x is equal 3 over 2, or 1.5. So we'll put that in here somewhere. And I'll draw this line in as a dotted line. You'll see why in a moment. The other way, we could have just said the y-intercept is minus 3, put that point in, and the slope is 2. So we have a line going up, roughly like this, and this point would just be every time we move over 1, we go up 2. So over 1, go up 2, over another half, we go up another 1, so that's 1.5. So we could have got that. We got these 2 points like that. Okay, so this is a line, it's not what they asked us to draw. They want the absolute value. Remember what the absolute value tells us. It tells us if anything's bigger than 0, leave it alone. This part of the line is bigger than 0, it's above the 0 point. So let's just leave this alone and we'll fill that in like that. The next thing it tells us is if it's a minus, change it to a positive. So for example here, we got a minus 3. Let's change it up to a positive. We get a plus 3. Like minus 1 turns into a plus 1. Minus 10 turns into a plus 10. Whatever we get the whole line bounces up like this, roughly drawing. So that's a sketch of this drawing. What the examiner wants to see is this number 3 here, and sorry, I never put it in, 1.5 or 3 over 2. And they probably want to see the minus 3 down here. That's the full marks for question 1 part A. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. Now for part B, we have an inequality. 3x minus 1 is less than the absolute value of 2x minus 3. This absolute value here is the same as we dealt with in part A. And there's a reason for that. They want you to do this question a certain way. There is 2 ways to do it. I'll sketch out at the end the second way to do it. But I'll do it the way they were trying to help you do it. They made you draw this picture to help you answer this question. So how do you do this? I'm going to treat this as a function on the left and a function on the right. The function on the right we drew here. This is the sketch of this right hand part of this inequality. Let's do the same, let's do a similar sketch for the left hand side. What I mean there is I want to sketch the line y is equal 3x minus 1. That's the left hand side as a function. We can draw it on the same picture over here. The minus 1 gives us a y-intercept of minus 1, so we'll put that in somewhere there. And then we have the 3, it gives us a slope. So we have a much steeper slope than 2. This was a slope 2. So this slope goes straight up like this, and it goes down like that. You could get this x-intercept there. That would be, I guess, 1 over 3. Yeah, if we 1 divided by 3 would be this point there. I don't really care. All I want is this rough drawing we already have. Let's look at this question again then. This function is less than this function. When does that happen on the drawing? It's less than here. It's less than everywhere on the left. Everywhere left of this point, that's less than. After that point, it's always bigger than. It's actually, they're separating as they go up here. So the answer to this question is x is less than whatever number x is here. Whatever number these intersect at. So what this question really boils down to is, forget the inequality. You can say 3x minus 1, when does it equal 2x minus 3, or the absolute value of it? That's what you can boil this question down to. And you can even get it better than this. Forget this absolute value. You can say 3x minus 1, when is that equal to minus 2x plus 3? Where did I get this? This is the line that bounces up. This is the minus part of this inequality, which is, we know what we're dealing with because we drew the picture. The picture tells us it's this bounce part. If you solve this equation, 4x, you will get this point, and we can just put it in here as our final answer. So let's do that. Bring the 2x over, we get 5x on the left. Bring the minus 1 over, we get 4 on the right. X is equal to 4 over 5. So this is the x value where these intersect. So we can say the answer is, when is this less than there? Everywhere left of that, which means x is less than 4 over 5. And that's the answer to part B. Okay, I recommend you do it the way I just showed you, using the sketch, but it is possible to do it without the sketch. It's very often they ask this question and they don't ask you to do the sketch first, so lots of students do it. It's not too difficult. I just like having the sketch. We just need to remember how an absolute value works. Absolute value is really 2 different possibilities, a plus and a minus possibility. So we can split this into 2 worlds. We can split this into 3x minus 1 is less than 2x minus 3 when this is bigger than 0. And we need to, I've left out a bit of room there. We need to have this as 2x minus 3 is bigger than 0. When that's bigger than 0, we're in this world. And then the other possibility is 3x minus 1 is less than minus 2x plus 3. That's the, if in here was minus. And that would be the case when, as I said, 2x minus 3 is less than 0. Because when this is less than 0, the absolute value kicks in and changes the sign of everything. That's how we get this sign change. So we just solve this, we rearrange it, 2x comes over, we have x on its own, is less than minus 2. But remember the world we're in. We're in the world where 2x minus 3 is bigger than 0. That means x is bigger than 3 over 2. So this doesn't make sense. We're in the world where x is bigger than 3 over 2, and they're telling me x is less than minus 2. So this one just doesn't count. It doesn't make any sense. To do this one, it's just like we did here. We'll get x is less than 4 over 5. And let's check what world we're in. We're in the world where x is less than 3 over 2, which does agree with this. Less than 3 over 2, just in case you're don't believe me, there's 1 and there's 2, 1.5 is here. We're in the world everything left of this, and our answer is talking about a world everything less than there. So this is fine. This world is fine. That is the answer. So it is a lot quicker to do than thinking about the drawing. But I just find students, and even me or any teacher, make a mistake when dealing with inequalities and moving things around. A drawing is much easier to do it. Okay, that's it for question 1. If you have any follow-on questions or you see any mistakes I made, let me know in the comments. Do me a favour, tell me whereabouts in the question you're talking about. It really helps me answer you. Thanks for watching. Have a great day. In question 2, they give us this quite intimidating looking equation with natural logs in it and two variables, p and q. They ask us to find q in terms of p. So what that means is they want us to rearrange everything so we get a single q on its own. It's not too bad because there is only a single q in this equation. So at the end of this whole thing, we want q is equal something here. Once there's no q's this side, once it's just p's, you've done what they asked. Although we'll see as we go through the question, we'll get to an answer halfway through the video that I think is okay, but we could get it a lot neater. And I'm not sure if the examiner would take a mark away if we stopped at the middle point. I'll explain what I mean as we go on. Okay, let's rearrange this so q is on its own. We'll take the term that q's in, this term here, and move it around so this is on its own. Basically, I'll move these two over the equals. They're both taking away. We'll destroy them by adding, they're both adding, so we'll destroy them by taking away on both sides. We'll be left with minus half natural log q plus 1. This term hasn't moved. The other side, this term 3, still there. These two get destroyed, and in their place appears this side a minus natural log p and a minus natural log p minus 1. Next thing we can do, we're sort of peeling away the things around this q. This minus a half, that can be got rid of, that can be destroyed quite easily. Multiply it by a minus 2. So that will get just a plus 1 over here, meaning it's just natural log q plus 1. And on this side, multiplying it by minus 2, we'll get a minus 6, a plus 4 natural log p, and a plus 2 natural log p minus 1. Next thing, we need to destroy this natural log. How do we do that? We put both sides e to the power of both sides. What I mean, I'll save myself a little bit of ink writing both sides. I'll just move this equals. I'll put an e here, an e here. We'll put the equals down here and a big bracket around that. So all I've done is everything on the left went over the power of an e. Everything on the right went over the power of an e. So I'm allowed to do that because I was equal to both sides. But look what happens on the left. The e and the natural log destroy each other. And we're left with, let me clean that off, and we're left with q plus 1. I would argue, I'll continue to save myself a bit of ink here by moving this plus 1 now. That becomes a minus 1. I would argue this is the correct answer. It's full marks. They asked for q in terms of p. That's what we have here. But we can definitely get it a bit neater than this. And I wouldn't be at all surprised if they take away half a mark or even a whole mark for leaving your answer like this. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. So let's try and clean it up. We're going to use the fact of the rules of powers. So we have something here with all this to the power of it. So what happens when something's adding in a power like this? We're left with e minus 6. These are just like multiplying them. It would be e to the 4 natural log p, and this would become e to the 2 natural log p minus 1. It'll clean it up a lot. I'll keep forgetting this minus 1, so keep an eye on me. Q is equal. This is better than this, maybe. No, maybe not. Actually, no, you know what? This is neater than this one. But we're tantalizingly close for this e and this natural log to destroy each other. We can't do it because the 4 is in the way and this 2 is in the way. So we have to use another rule of powers. If I'm just looking, let me take it out here to the side for a moment. E to the 4 natural log p. We can rewrite that as e to the natural log p to the power of 4. Or we could do it the other way around even. We can rewrite that and look what we're left with. Sorry, I have this bracket in the wrong place. Like this, or that's actually the same. And what we have now is these two can destroy each other. We would be left with a p. The e and the natural log would destroy each other and leave just the p and the power of 4 up here. So this would become p to the power of 4. Another way we could think of this, actually I'll do it on this one, the other way as I write out the next line. So e to the minus 6, for the reason I just said up there, not e, this would become just p to the power of 4. Let me do this a different way. I'll do it up here again. E to the 2 natural log p minus 1. We can use the rules of logs to rewrite this as e to the natural log p minus 1 to the power of 2. The same thing here, sorry, not the same thing. Natural logs, when they're multiplied by something, it's the same as what's inside it being put to the power of that. But again, e and the natural log destroy each other, and for the same reasons, we would have got the same answer doing it this way, is what I'm saying. Two different ways we could have done this. But we'll be left with p minus 1 squared. Minus 1 at the end again. This is a much better mark. I'm nearly sure you get full marks for leaving your answer like this, although you will probably see most answers being left like, let's see, p to the power of 4, p minus 1 squared over e to the power of 6. We just, remember, minus 6 just gets bottom row and a minus 1 here. I'd say this is probably this is the way I'd leave the answer, although I would expect you to get full marks on this line. I think you probably lose some marks, lose something on this line or this line, even though it's mostly correct. Okay, that was a long answer to a short question, if you weren't worrying about all that. That's it for question 2. If you have any follow-up questions or see any mistakes I made, let me know in the comments. I'll do my best to get back to you. Thanks for watching. Have a great day. In question 3, we're going to be dealing with complex numbers. And I'd say this question is particularly tricky. I'm guessing a lot of students had difficulty with this one, even though most of you guys are probably pretty good at just dividing complex numbers or getting the modulus of a complex number. This question had a few extra steps to it. They didn't just want you to divide this, and it's not even written out in a normal way. They told you that this is real. This is an element of the real set. That means there's no complex part of this. So how does that help us? We'll leave this for a moment. We'll just deal with this idea over here. Now I can see there being probably a nice, interesting, smart way to solve this. I haven't looked at it too. I had a quick glance at it and I was like, I'm not sure I see it, but I'm sure there is a trick there. I'm going to do a little more brute force of a way. I'm going to, first of all, z is a complex number. So I'm going to rewrite z as z is equal, and you pick any letters you want. I'll use a plus bi. I'm going to write it like this, where a and b are just real numbers themselves. And I'm going to rewrite this whole thing here with this new numbering way. So instead of z, I'm going to write, let's put it all down here, a plus bi plus 5i. Instead of z in the bottom, a plus bi minus 5. And I'm going to rearrange this so all the real parts are together and all the imaginary parts are together. So what I mean is this top row will now become a is the only real part and b plus 5 is the imaginary part with an I here. This is the same thing. On the bottom row, the a minus 5 are the real parts and the bi is the imaginary part. So remember what they've told us about this. They've told us that this is real. I'm sorry, that's probably not, that's not what I meant to say there. That is important what I said. It's going to become useful in a minute. This is real, but I don't see how that obviously helps us yet. We can't just say like b plus 5 is 0. We'd be left with a divided by some imaginary part, and so it would still be imaginary overall. So let's just go ahead and try and divide this out. I rewrote this up here just so I had a bit more room. And let me go over how to divide again, just in case you're unsure. I want you to remember that any number, think of this whole thing as a number. I won't draw a circle around it, it'll get a bit messy. But this whole thing here as just one number, and any number, whether it's complex or not, you can multiply by 1. So if we multiply any number, 5 by 1 is still 5, 8 by 1 is still 8, minus 20 by 1 still minus 20, 8i by 1 is still 8i. So we can multiply this by 1 if we want. Let me put that in, multiply by 1, because I'm going to do that sort of. The next trick is a number divided by itself is 1. 8 divided by 8 is 1, minus 20i divided by minus 20i is 1, 8 plus 4i divided by 8 plus 4i is 1. So we're going to use that fact to, instead of putting 1 here, I'm going to put a minus 5 minus bi on top, a minus 5 minus bi on the bottom. Hopefully you remember this. This is the conjugate of this one. We've just changed the imaginary part of it, the sign of the imaginary part. But what I think a lot of students forget to realise is this is all 1. That's why we're allowed to do it. This is just the same number divided by itself. Why do we pick this one in particular? Why do we pick the conjugate? Because what we're going to see in a moment, when this multiplies this, all the i's are going to disappear. You don't have to multiply this out, by the way, if you know where this is all going. I'll multiply it all out just so everyone's on the same page. We can get away with just multiplying a small part of the top row though. So just to point that out. Let me go ahead and start multiplying things out then. Top row, real by the real, we get a times a minus 5. Real by imaginary, we get minus abi. Imaginary times real, we get, this is an important one, so I'll write all this out. I'll leave the brackets. B plus 5 multiplied by a minus 5. And that leaves an imaginary number. Sorry, this one's also important. And lastly, imaginary by imaginary. This isn't actually important. We'll just put minus b plus 5 times I squared. The bottom row. None of this is important. I'm just going to show you what we get. We get a minus 5 times a minus 5. I'll just write a minus 5 squared. We get a minus 5 times minus b, I. And we get b times a minus 5, I. These are just opposite. This is a minus b and a plus b. They just cancel. There is no I on the bottom row because we picked that. And we're left with minus b I squared. Sorry, I said there's no I. I squared is minus 1. So that just turns into a minus, which turns that into a plus. That just turns into a minus, which turns that into a plus. Remember what they told us about this whole mess. Let me rewrite it again. No, I won't bother rewriting it again, to be honest. Remember what they told us about this whole mess. They told us it's real. Going back to the start, they told us the division part is real. This is real. This is real. That means there should be no i's in this whatsoever. We got rid of the i's on the bottom row. We did that. We're left with these i's up here. They're telling us it shouldn't be there. It should be 0. Everything on the top row with an I should be 0. So I can write minus AB, this part, plus b plus 5 multiplied by a minus 5. All of this must equal 0. It must add up together to get 0, to get all the i's gone. And we can clean this up a lot here. We'll get minus AB plus AB, this is b times a here. Minus 5b plus 5a minus 25 equals 0. The AB's cancel. We're just left with, divide everything by 5. We're left with an a here, minus a b from here, and a 5 here. I've divided everything by 5 and I've moved it over. We get this out of this fact. The fact that this is real tells us that. You didn't have to do all this work. You could have, once you got to this line, you could have just we could have wrote this top row. And even at that point, you could have just said, the only thing I'm interested in is a multiplied by minus bi and b plus 5 multiplied by a minus 5. which I finally did up here. You could have jumped a lot of that. You could have saved yourself a lot of work here. This is not enough to solve. We still don't know what A and B is. They want us to write out, oh sorry, they've used X and Y. my apologies, I should have used X and Y the whole time. I'm sorry, I'm sure you can get over that fact. We still need to use the fact that Z, the modulus of Z is equal to the square root of 17, or A, I'll stick with my A and BI. A plus BI, the modulus of this is equal to 17. Remember how the modulus works, that's just A squared plus B squared, or the square root of that is equal to the square root of 17. That's just A squared plus B squared is equal 17. We have these two simultaneous equations. I will clean the board off now and we'll solve this, but hopefully you're all able to solve this at this point. But yeah, we're just down to a quadratic simultaneous equation. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. Okay, let's go ahead and solve it then. Let's just rearrange the first row so we have A is equal B plus 5. We could have also got B is equal A minus 5. Makes no difference really. Once we have this on its own, we can easily change this to A squared is equal B plus 5 squared. Now we have an A squared here that's independent of this line. We'll combine them. Well, let's write this line again. I'll show you what I mean. Instead of A squared, we're going to write that. B plus 5 squared. But I'm writing this line. I'm just, instead of A squared, I'm putting this in. Plus B squared equals 17. We've got an equation with only one unknown. We're going to get a quadratic, but still, we're nearly there. Let's clean this up. We'll get B squared here plus 10B. That's 5 times B and B times 5. Plus 25 plus B squared is equal 70. And let's clean it all up. We get 2B squared plus 10B plus 8 is equal 0. Oh, we can clean that more. Divide everything by 2. B squared plus 5B plus 4 is equal 0. Let's hope this is comes out evenly. It does, thankfully. We have B times B. Two numbers multiply to get 4 and add or take away to get 5. That's 4 and a 1. They will all be plus. So our two answers here would be B is equal to minus 4 and B is equal to minus 1. Should we be surprised to get two answers? Read the question. It says give your answers. There's an S at the end there. It's a plural. So we knew we were going to get more than one answer. So you should be on the lookout for that. This is not it. So many students leave this as their final answer and throw away 1, 2 marks. I think the examiner has to throw away if you've only leave this. They want A. We found B. We still need A. A minus 4 is equal 5. That's this first line here. A take away whatever B is equal 5. That's A plus 4 equals 5. A is equal 1. These answers go together. Remember what they should look like. 1 minus 4i. That's this is Z. Remember, Z was equal, let's write it up here. Z is equal to A plus BI. Or if you had read the question better than I did, Z is equal to X plus YI. Either way, this is the answer they were looking for on this part. On this part, A minus 1 is equal 5. A will equal plus 1 will equal 4. Combine them, 4 minus I, minus 1i. These are your two answers to question 3. Okay, that's it. If you have any follow-up questions for this, or you see any mistakes I made, let me know in the comments. Do me a favor, tell me whereabouts in the video you're talking about. It helps me answer you. Thanks for watching. Have a great day. In question 4, they give us two parametric equations, And they want us to solve, they want us to find an equation of a tangent to a curve that's made by these guys at a certain point. Let's write that point out. E3 is going to be the point. Let me just remind you what the parametric equations are or how they're useful. We're dealing with a xy axis. We're dealing with an xy as always. So when they're talking about a tangent to a curve, we're still dealing with this xy. The t comes in that it's hard, or I'm fairly sure impossible, to write a function that goes backwards. Let me just make up some weird function. It goes backwards like this. We can't make functions that go backwards with just y and x. But if we add an extra equation, an extra variable, like t for example here, we can now make lines do lots of weird things like this. So that's useful. But still, that point they told us is still some point that fits somewhere on this weird shape, like here, E3, and we're still just going to find a normal tangent to it. So to do the question sort of backwards, or, well, it's how you should think about these often. Remember what they're asking. They're asking for an equation of this line. Remember what you need for the equation of a line. You need a point. We have a point, E3. And we need the slope. So what we're looking for is the slope of this line. And we're still in the yx axis here. So that means what we're looking for is dy dx. I feel that trips up a lot of students. They start thinking, well, the slope, it's okay to get the dx dt or dy dt. No, we're still looking for dy dx in this world. To help us get dy dx, we are reminded by the fact that dy dx, let me write it again with just a bit of a gap here. Dy dx is the same as dy d anything, dp, dg, or in this case dt, once the dt's cancel. Calculus is very confusing in that these aren't really fractions when you go on to college and do multivariable calculus. Not that I fully remember this, but it doesn't really fully work like fractions. But for our level, for single variable calculus, for A level, it does. So we can just think of this cancelling this. So to get this dy dx, let's just focus on getting dy dt. And oh no, I forgot something. This isn't dx dt though. That's the problem. We can rewrite this again, and you often see it like this in the book: dx dt divided by dy dt divided by dx dt. This is identical to this. Remember how we divide by a fraction? We turn it upside down and multiply. This is the same. So what we want to concentrate on now is finding dy dt and dx dt. Both of these are, well, they're questions in their own rights, I guess. I'm going to do them quite quickly, otherwise we'd be here all day. Dy dt. We're going to need the chain rule to do this. If we rewrite this 2 here like this, because that's the same, that's just a short way to write it. This is the chain rule. The 3 we can ignore, we can leave that till later, put it out front. What this is saying is we have something to the power of 2. We know how to differentiate that. That's 2 multiplied by that something. And then the chain rule says, hang on, you can't just treat this something like it's an x, or in this case a t. So we're going to need to use the chain rule on that. What's the derivative of tan t? That becomes a secant squared of t. So that's our answer here. 3 multiplied by 2 becomes 6, obviously. Let's do similar for x. We will treat this as just e to the power of something. Well, the derivative of that is easy. It's e to the power of that something. But again, we have to use the chain rule and say, hang on, that something wasn't just t. So you better multiply by the derivative of that. Again, the derivative of tan t is secant squared t. Okay, we have these two. Let's divide it like this. On the top we get 6 tan t secant squared t. On the bottom we get e to the power of tan t secant squared t. Thankfully they cancel. So we're left with this nice little function here. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, Probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. This function is of dy dx. This is dy dx. But remember, we know what point we're interested in. We know we're interested when x is equal to e. So we just put x equals e. Hang on though, there's no x. That's not alright. We know y is equal to 3. Oh, there's no y in this either. So we're at crossroads here. You can answer this two different ways. First thing you can do is you could put e and 3 into these functions up here and solve for t. Find out what t is equal. In both of these, I guess either of them are fine. They both should find the same one. Find out what t is equal and put that in. That's one way. What I'm going to do is, let me block off an area here. I am going to point out that we want e to the tan t. Well, I know what e to the tan t is. It's equal to x. So I'm going to rewrite this as, well, let me just write over here. The bottom row is just going to turn into x. And x is just e. So that bottom row is equal to e. The top row is somewhat similar to this. Let's try and rearrange this so we just get 6 tan t. So this is 3 tan t squared is equal y. Let's move the 3 over first of all. Divide by 3. Square root of both sides. We get tan t is equal y over 3 square root of that. But I want 6 tan t. So just multiply both sides by 6 and we're done. Because remember, y is just 3. 3 divided by 3 is 1. Square root of 1, it's gone. This is all just equals 6. 6 tan t is equal 6. 6 tan t is equal 6. This answer, this 6 over e, this is our slope. So my drawing does go up at least. This is the slope, this is the point. I'll clean all this off and we're just left with getting the equation of the line. Oh, before I clear this off, I was just looking at my notes there. I was a bit cheeky at this point. I just got the square root. That should have been a plus or minus here. Except for the fact if we were to fill that back in, so tan t it should equal 1, plus or minus 1, we sort of had there. If we fill that back in over here, plus or minus 1, remember this is e. E is equal to e, not e to the power of minus 1. So the minus 1 couldn't be true. Would you lose a mark for what I wrote here without adding that in? I don't think so, but maybe. Maybe. You should have had a plus or minus there and you would have had to. So from this you would get a plus or minus. And you'd have to look to this equation to solve that for you. Because you knew from the question there's only one answer. They didn't ask to find the equations, just the equation. So yeah, apologies for that. So we only get one answer, we get 6 over e. So if you got two answers, like minus 6 over e as well, that's where you went wrong. It's just this equation discounts that fact. It can't be a tan t can't be minus 1 because of this. Okay, just wanted to clear that up. So what we're left with is we have a point and we've now got dy dx, or I'm just going to write as m. The slope is equal to, what was it again? 6 over e, I believe. Yeah, 6 over e. We just get the equation of a line from this. A couple of different ways. I just get y is equal mx, or 6 over e x plus c. And then we know what an x and a y is at a certain point, so we can find what c is and then just write this again. So at a certain point y is 3 and at a certain point x is e, so they cancel. So c must equal 3 minus 6, or c must equal minus 3. So just rewrite this line again. Y is equal 6 over ex minus 3. That's the equation of a line at this point on the parametric equations that they gave us. Okay, that's it for question 4. If you have any follow-on questions or you see any mistakes I made, let me know in the comments. I'll do my best to get back to you. Thanks for watching and have a great day. In question 5, we're given this very messy looking polynomial, and we're given a couple of clues about it, but we're asked to find P and Q basically. The two clues we're given is when you divide this by a certain thing, we have here x plus 2a. When you divide by that, you get a remainder of minus 22a cubed. And when we divide by 3x minus a, you get a remainder of minus a cubed. Right, there's two ways to do this question. Now we're going to have to do something twice anyway. So I'm going to be able to show you both of the ways you can do this question. Basically, I'm going to use both of these pieces of information. Let's put group them like this. I'm going to use both these pieces of information. I would advise you to do the same thing each time, but just to show you how to do it, I'm going to use a different method each time. The first method I'm going to use is probably a lot messier, but yeah, it's just definitely a lot messier. It's probably the worst way to do it. It's going to be long. The second way is a lot cleverer. But a lot of students might not realise the second way. So use whichever you rather. The first way is I'm going to actually use long division. So let's go ahead and use the first one here. I'm going to divide x plus 2a into this. And I'm going to find a remainder. And I already know what a remainder is, so I'm going to equate them and get an equation out of it. Okay, so long division. We don't have to be too careful of what goes up here. I can even skip right in it if you want, because we're only interested in remainder. But still, I'll do it as carefully as I can. Right, what number multiplies by x to get 3x squared? That would be 3x cubed. That would be 3x squared. Multiply 3x squared by x, we get the same thing. 3x squared by 2a, we get 6ax squared. We'll take these away, that cancels. Here we get pa minus 6a times x squared. And we take down the next term, 7a squared x. Okay, what multiplies by x to get this mess? And this is where it starts getting really messy. It's pa minus 6a x. This multiplied by x would equal this. So we just jot that. I'd save your ink right in this part, to be honest. The important thing is we're multiplying this by 2a and we're putting it underneath this one. So that'll become let's see, 2pa squared minus 12 a squared multiplied by x. So that's this term multiplied by 2a, put a little plus in there, and underneath this we're going to take these away. These cancel. I'll save the effort writing these in future. So this all becomes 7a squared minus 2pa squared minus, so plus 12a squared all times x. Let's clean this up first. We have a 7a squared and a 12a squared. So that's minus 2pa squared plus 19a squared, all multiplied by x. Let me stop here and remind you, the second method I'm going to show you is a lot faster. So we won't have to do this twice, thankfully. Okay, let's take the next term down. We have q times a cubed. That's hard to say. Okay, what multiplies by x to get this? A mess up here, minus 2pa squared plus 19a squared. That will multiply by x to get this term. Okay, this multiplies by x, gets the same thing down underneath. I won't bother writing it. But this multiplied by 2a, that comes out as minus 4pa cubed plus 38a cubed. Yeah, okay, and it's the final one. This minus this, I'll write it over here. We have a q minus, so I'll leave the a cubed outside everything. Q h cubed to take away this, so that becomes a plus 4p. Again, I'll leave the a cubed out last. Minus 38. All of this times a cubed. That's the remainder if we do it this slow and messy way. But they already told us the remainder. So this guy is equal minus 22a cubed. The a cubes cancel and we can equate this. We have q plus 4p minus 38 is equal minus 22. Bring this over and we get 16. Q plus 4p is equal 16. Right, that's the information we got from this first term. If you were to do this mess again, and you can go a lot quicker if you don't have to say everything out and you don't have to write everything out. If you did the same thing with the second term, you would get another q and p, and we'd have a simultaneous equation. We could solve it, we could get an answer. I'm going to rub this out though, and I'm going to show you another way, a lot shorter of a way to use this information to get a equation with q and p in it. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. Right, let's look at that shorter method to doing this question. So if we think of this polynomial as a function, fx, what we're really being told here is, you can think of this as like a factor. I'm not sure if it's called a factor when there's a remainder. So if there's a remainder 0, we call it a factor, and a root. I'm just going to use the words factor and root here, understanding that there is a remainder. So if we call this a factor, that has the first one, the root would be 2a. But in this case, it wouldn't equal 0, it would equal minus 22a cubed. So that's what we know from a remainder and a factor. So to put that in terms here, this second factor here, 3x minus a, if we think of this as if it equals 0, as we usually think of it when there's no remainder, and we rearrange this, we get x is equal a over 3, and we call this the root. So let's just change this sign, divide by this number. That's the root and the factor. If we put this root in, knowing there's a remainder, that's what we will equal. When there's a 0 remainder, we put the root in, we get 0. When there's a remainder minus a cubed, we put this root in, we get minus a cubed. I hope I'm not confusing anyone too much with using the words root and factor, because I think I'm using them wrong. So what I mean is, if we put in fa over 3, put that into this, and that'd be 3, let's see, a cubed over 3 cubed, which is 27, plus a squared over 3 squared, which is 9, plus 9a squared a over 3, plus a cubed. I know this is equal to the remainder they told me here, minus a cubed. Lot faster, a lot cleaner this way. We have a function with a, p and q in it, but here's the great thing, all the a's match. We have an a cubed here, because just leave a minus 1. We have an a cubed here, an a and an a squared, that's an a cubed. A squared and an a, that's an a cubed. Everyone had an a cubed in it. We can divide everything by a cubed and leave this. Let's clean this up. This would become 1 over 9. This would become p over 9. This becomes 7 over 3 plus q is equal minus 1. Here's another function. This is the one we got from the first part, q and p. This also only is q and p. So we have a simultaneous equation there. Let's clean this up first though. Multiply everyone by 9. That should be a 9 down there. Multiply everyone by 9. We should clean this up a lot. 1 plus p plus 3 times 7 is 21, plus 9q is equal minus 9. We have p plus 9q is equal, let's see, that's minus 30 minus 31. So we have two equations with P and Q. Let me clear some room up here, and we'll solve this simultaneous equation. Okay, here we have the two equations. First of all, apologies, my 9 and my Q look a lot alike, so I hope that's not confusing people too much. We just need to equate these. We can multiply this one by 9 or this by 4. I'll multiply the second one by 4 just to get rid of this 9Q, because it's really awkward to see. So this second row then becomes 4P plus 36Q is equal to minus 124. We have these two here then are sort of equal to the other. If we take this row minus this one, the 4P's will disappear. So we'll have 36 minus 36Q minus 1Q is 35Q. Minus 124, take away another 16, we get a minus 140. Let's see, 7 goes into both of these, that's 5Q, and 7 goes in 20 times, or 5 goes into both of them. Q is equal minus 4. That's half our answer. Yeah, they want P and Q. Go back to whatever one you want. P here, P plus 9 Q's, well that's minus 36 is equal minus 31. So what do you have to add on to minus 36 to get minus 31? Well, let's do it slowly. Add 36 to both sides, we get 5. P is equal 5. There are your two answers. P is equal 5, Q is equal minus 4. I just really like doing that long division I did at the start. I can't explain it. I know it's a little longer. I know it's a little messier. I've always liked doing the long division. Other than that, I cannot recommend doing that way. Clearly the faster way was to put in the root and knowing what the remainder would be and equating it that way. But there's often choices in a lot of these maths questions. Okay, that's it for question 5. If you have any questions or see any mistakes I made, let me know in the comments. I'll do my best to get back to you. Thanks for watching. Have a great day. In question 6, we're dealing with complex numbers. There is 2 different ways to view complex numbers. The most common one we do is just the A plus BI. The next common way, which can be split into 2 different ways, is polar form. And that's we can use cosine x plus I sine x. But that can also be wrote in this form. And this would probably be one of the most common ways people use complex numbers in real life, when we get to college as well and stuff. There's a lot of information there. When you're dealing with things that go in circles, this is a great way to deal with them, which we'll see a bit more later in the question. Okay, so you're given these 3 complex numbers, Z1, Z2 and omega. They ask us to state the values of omega multiplied by Z1 and omega multiplied by Z2. Okay, we just need to multiply it first. I'm sorry, I was getting a bit mixed up there. Okay, multiply these 2 numbers. Let's write them out first. This is a 2, by the way, not a Z. This is equal to 2e half pi I multiplied by 3e to the power of a quarter pi I. You don't have to write all this out. You can actually do all this in your head, which I will do the second part that way. I just want to point out how we can multiply all this. These are like 4 terms multiplying. This term, this one, and this one. Multiply doesn't care where you put it. So 2 times 3 can be done. Getting 6. Next, E and E. They're both the same number. They have different powers. So how do we deal with that? The powers can add. When the same base multiplies, the powers can add. So we're left with E half pi I on this one plus a quarter pi I on this one. They both have pi I, so we're really just adding a half plus a quarter, or 2 quarters plus 1 quarter, 3 quarters. So the final answer is 6e 3/4 pi I. That's how we add them. That's how we are sort of adding together there. That's how we multiply these two complex numbers. And this is one of the great powers of complex of writing a complex number like this. We can do it so quickly. This one I will do just in my head. Omega multiplied by Z2 is the two amplitudes, the number in front. We often call them the amplitudes. The two number in front, 2 multiplied by 3 over 2. That'll become 3 when we multiply that together. Then the powers, we just add them together. They're often called, I think they're the frequency or they're the wavelength. I think they're the frequency. We add them together. It's a half plus a sixth, or another way to say that is 3/6 plus 1/6 is 4/6, which is, I guess, 2/3. So it's E 2 over 3 pi I. 4 over 6 is 2 over 3. That's the answer to part A. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. For part B, they want us to make a sketch on an argon diagram. Remember, a sketch it can be rough, doesn't have to be too exact at all. They want us to put Z1 or a zeta 1 and zeta 2, and they want these two things we just did, omega zeta 1 and omega zeta 2. We want to draw all them. Another great thing about complex numbers like this, they're really easy to draw. Let's start with Z1. What we have here is this number here in front of the I. This is the angle of the direction of where this point is. So this a quarter pi. This is 0. This is half a pi. This is pi. This is 1.5 pi's, and that's 2 pi. We're talking about a circle here. And not in this question, but in future you could have like 10 pi. That just goes around 5 times. So you can have minus pi, it just goes the other way. Okay, so where's a quarter pi? So as I just said, that's half pi. Quarter pi is here, like 45 degrees, somewhere up there. This number tells you how far up. This 3, we just go 3 up. I'll put it around here. So to tell the examiner in a sketch what you've just done, I would put in a pi over, pi over 4 here as the angle, and the length 3. Sorry, I'd put in maybe a straight line there. Something like that. That'd be fine for the examiner. Okay, to draw the second one, this one is 1 over 6 pi. So 1 over 6 would be, 3 over 6 would be here. So we'd split this into 3. So it'd be somewhere down like this. And we'd want to go 3 over 2 out. That's a half. Oh, sorry, there's a bit of a mess then where I have my quarter here. So it would be around about here. And again, I might show the examiner that this is pi over 6. And I'd maybe just put a little arrow in here for the examiner. Pi over 4 was this one. Okay, continue on. This number here, 6 out and 3 over 4 pi. So that's 3/4 of a pi. That's 1/4, 2/4, 3/4. Goes out here, and it's 6 long. So we go out around 6. Again, just tell the examiner you went out 6, you went out... Geez, there's not really enough room to show the examiner everything here. It's a 3 over 2. I'd want to write somewhere though. I'd want to put in the angle here. I'd put in maybe pi over 4, just as this angle. Although you could tell them 3 over 4 pi and show it all the way back. And then finally we would have this one, 2 over 3, 2/3 pi. So we split this world into 3, 1, 2, 3. 2/3 would be somewhere up here. And I'd go out 3, something like that. Again, I'd tell them it's 3, and I'd tell them some number here being maybe pi over 3. This is a sketch. These 4 points, something roughly like that, is all they wanted to see. I'd probably have a bit of a complaint with the examiner that they They really put the points on top of each other here, so you weren't able to show them the information to write in the... Because usually when you're sketching something, you want to give the point, but you also want to give 2 bits of information, often x and y. But in this case, I want to give the radius, the length from the center, and I want to give the angle. And honestly, there wasn't that much room to do it. Okay, on to part C. State the geometric effect of multiplying Z1 by omega. What happened going from here to here? And it might not be obvious, but again, it's same thing happened going from here to here. Hopefully you remember this because you learn it in class, multiplying complex numbers. What they do, especially in polar form, we can see what happens a lot clearer. This number in front, that just straight up multiplies it. So we can think of that as enlarging it. It enlarges it by 2. It doubles the length. 3 became 6. 1.5 became 3. So that's what this does. It makes it twice as long. This number in here, all this does is adds to it. That's what we did when we were adding to it. And you can think of that as rotating. It adds 90 degrees to the angle. The angle was here. It's now here, 90 degrees away. This angle was here. It's now here, 90 degrees away. If I draw a whole new one, no matter what the point was, let's say the point was here. If I multiplied by Z, I know what would happen. It would go 90 degrees to the left, like that, and it would get twice as long. So let's see, rotate that around and it would get twice as long. So I can tell you rough, if they drew a picture, which this would be a great question for the class, they might just draw a random picture, a random Argon diagram with a random point, no information of where it is, and they would ask you to estimate what would happen if you multiplied this point by omega. And you should be able to do that. It's just 90 degrees and double the length, because that's what's happening when you multiply anything by omega. Okay, that's it for question 6. If you have any follow-on questions or see any mistakes I made, let me know in the comments. I'll do my best to get back to you. Thanks for watching. Have a great day. For question 7, we have quite a common question. They've given us a trigonometric expression, and they've wanted us to put it in this form. And this form being just sine, or sometimes it's just cosine. With some new angle. So sine with some new angle and some factor out front. How do we do it? Well, if they want this to look like this and they just want us to find what or and alpha is, let's just put it equally to each other and expand both sides out, because we know lots of rules about sine and 2 angles, and in fact over here sine and 2 angles. Let's expand both of these out and then try and equate them together. Hopefully we'll be able to find a solution for or and alpha. To do that, let's remember what sine of 2 angles are. It is sine of the first angle multiplied by cosine of the second angle, plus cosine of the first angle multiplied by sine of the second angle. That's this expanded. Sorry, it should be a 5 here as well. And then we still have the minus 4 cosine x. On this side, let's expand this out as well. We have sine of the first angle again, multiplied by cosine of the second angle. The second angle is a minus, so that can be wrote as cosine of cosine of a minus alpha is the same as cosine of alpha. Plus cosine of the first angle multiplied by sine of the second angle. I'll leave the plus off for a second and you'll see why. So that's cosine of the first angle, which is x, and sine of minus alpha. Well, sine of minus alpha is the same as minus sine alpha. So that plus became a minus. That's why I left it off. Oh, sorry, I keep forgetting my second or there as well, my multiplier factor. So this is what we have if we equate all these out. Now remember, we can just put this into a calculator or look up a table of cosine pi over 6 and sine pi over 6. So they're just numbers. We'll put them in a few moments. What I want you to think here is the sine x on the and the cosine x on both sides. So there's a sine x that side, is cosine x these should equal, the coefficients on each side should equal. What I mean by that, let's group all the sine x. It's already done here. It's 5 cosine pi over 6 sine x. That's on the left. On the right, we have, and they will equal, or multiplied by cosine alpha sine x. The sine x's on the right should equal the sine x's on the left. And we can do the same thing with the cosine x's. Cosine x is a bit more. There's a 5 sine pi over 6 minus 4 of the cosine x's on the left. And on the right we have minus 4 sine alpha of the cosine x's. We can just cancel the cosine x's. That's what I mean. The coefficient of the cosine x's will equal. We'll cancel the sine x's. We have two unknowns. We don't know or, we don't know alpha. And this is just a number. We can put it in. Let me look it up now. Cosine pi over 6 is square root of 3 over 2. So multiply that by 5. We get 5 times square root of 3 over 2. And that must equal or cosine alpha. On the bottom row we have sine pi over 6 is a half. And so 5 times a half, 5 over 2, minus 4, which is minus 8 over 2, so that's a minus 3 over 2. That's equal or sine alpha. So this is a very common point to get to in these questions. We'll have or cosine alpha and or sine alpha equals two numbers. With this information, it's a simultaneous equation. Yes, you could try solve it a few different ways, but there's a couple of easy ways to solve it for or and for alpha. Let's do or first. If we take this one and square it, square both sides, we'll have or squared cosine squared alpha is equal to, I guess, 25 over 4 times 3, or 75 over 4. If we do the other one as well, that'll become or squared sine squared alpha is equal 9 over 4. Just minus 3 over 2 squared. Remember what happens when we add these together? Well, the or will be common, so or squared, and if we add cosine plus sine, that's just 1. Cosine squared plus sine squared of something is just 1. And if we add these together, we have 75 plus 9 is 84. 84 over 4, which is 21. That's or squared, so or is equal to the square root of 21. They told us or was bigger than 0. Yes, okay. So not plus or minus. We would have got plus or minus there, but or is bigger than 0. That's your answer for or. Let me just rub out a little room up here because it's not going to take much space to find alpha. We're going to work from these same two equations. We could have got alpha before or. It really didn't matter. We're going to take this one divided by this one. That's or sine alpha divided by or cosine alpha. So this divided by this is the same as this divided by that. So we get minus 3 over 2 divided by 5 over 2 multiplied by the square root of 3. Look what happens here. Or's cancel. So or disappears out of it. Just like the alpha has disappeared out of this one. It's very convenient like that. Sine alpha divided by cosine alpha. They combine to become tangent of tangent alpha. A lot of things cancel. Let's see, 2's cancel. The square root of 3 goes into 3 square root of 3 times over 5. Am I missing a minus somewhere? Yes, and I guess this is technically wrong, but the minus squared out. There should be a minus right here, which means the minuses can cancel. So that could be a plus. So I think over here when I got 9 over 4, from minus 3 over 2 squared, it's the same as plus 3 over 2 squared. So there wasn't really a problem with that from the mistake I had in. It would be a mistake here though to leave that. We do need a plus. Okay, let's just take the inverse of tangent of both sides. So alpha is equal the inverse of tangent of square root of 3 over 5. Put that into a calculator. How many decimal places did you want? 3. Oh, here it is here. And we get 0.333 as our answer. If you are finding my videos useful and would like to help the channel out, On top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. Okay, for part B, they give us this new equation that shouldn't look too new to you. And they ask you to solve that. They say hence solve it. Hence meaning use what you've just done there to solve this. So this looks just like what we had in the first part. 5 times sine, there was an x here, plus pi over 6 and so on. So instead of this equation, instead of this left hand side, we can write that as square root of 21, the or from the first part of sine, instead of the x, it'll be sine x. X is still pi, 2 theta, sorry. It's still 2 theta, so don't mix up there with just putting theta in. And then minus alpha, which you could leave in as, well, I'll leave it in as 0.333. They've made sure that it won't affect your, because this answer is correct to 2 decimal places, and this will actually just be off by half of this, I guess, maybe. But it won't affect your full answer. But if you want, instead of this here, you could put in whatever we had here, inverse tangent of, let me just double check, the square root of 3 over 5. You could leave that in, or you could leave it in your calculator so it's perfect. As it happens, it doesn't matter. You can just leave 0.333 in this case. So that's instead of this left hand side. That will all equal square root of 7. This is a lot more manageable than this question. And remember, if you weren't able to do part A, you can still do this. You can still just make up 2 numbers for or and alpha. Like pretend the or was 10 and alpha was like a half or 1 or 8 or whatever number you want. It might make it more difficult if you pick a hard number, but you can still attempt part B even if you couldn't do part A. Okay, once we're here, let's rearrange this and solve for theta. They want you to get answers. That's more than one answer. Well, we'll deal with the more nuanced part of this layer. Let's just get theta on its own for now. We rearrange this, divide both sides by 21. We get sine 2 theta minus 0.333 is equal, let's see, 7 divided by 21 is 1 over 3, but they're still square rooted. We can get the inverse sine at this point. And we'll get 2 theta minus 0.333 is equal to the inverse sine of square root of 1 over 3. And if you do that in a calculator, that comes out at 0.615, although we're coming back to this bit here. There's something special going on here. So you could rearrange this. Let me jump over here because I want to use a bit of room there again. You can rearrange this, add 0.333 to both sides. You'd get 2 theta is equal to, I don't know if I have this, but 0.948. Theta is equal 0.47 to 2 decimal places. That's a perfectly good answer. That is a correct answer, although it's not guaranteed to be a correct answer. Because they told you more things about theta. They told you theta was between 0 and pi. And they also said there's answers. So there should be more than one answer. I'm only getting one. So what went wrong here? A couple of ways to look at where I could have got multiple answers. Whenever you're getting sine or cosine, remember that there's multiple answers. My calculator gave me this answer. That's not the only answer. My calculator doing this sum here thinks sine looks like, doesn't think sine looks like this. Just gives this answer here. In this case, just gives an answer in this in this world actually, I think gives an answer between these 2 points here is what I believe the calculator will give an answer for. So my calculator just gave me this answer. The truth is there's actually infinite answers to give. What do they look like? Did I jot a couple of them down? Yeah, I jotted the second one down, which is enough. Instead of this answer, that my calculator could have also, instead of this answer here, you could have also realized this is an answer. Remember, we're in radians here. This number here is pi. This is 2 pi. So if we got, if the calculator told you this was 0.6 away from 0, well, this is 0.6 away from pi. So you take pi minus this number and you would get 2.326, I think. Basically pi times that. That's also a good answer. Another answer would be 2 pi plus 0.6. That's a perfectly good answer. Another answer would be minus pi minus another 0.6. These would all be fine answers. You should have 5 or 6 answers here. So this one would also work. 2 theta minus 0.33. Rearrange that, we'd get theta is equal 2.659 over 2, which equals 1.43. This is inside the world that they asked for as well. This was a correct answer. This was a correct answer. You might have to check other answers. Now, you don't have to, because we can think this through. But I would say, who knows where the answer could be? Sometimes they're not nice to you and giving you this nice area. Okay, to check that, draw a picture. Not this picture, unfortunately. Will I squeeze this in? Yeah, I'll squeeze this in here. I want to draw this picture here. Okay, this is a sine, but it's of, it goes twice as fast. This 2 times theta. It's not going over an entire 2 pi. It's going over only pi this time, or it's like, let's see, it's doing like this. Yeah, I'll just do it roughly. It's doing twice as fast. That's what this 2 theta will do. And this minus a number is offsetting it. Everything's going to be moved. It's minus, so it's all going to be moved to the right. So instead of hitting 0 here, it's going to hit here, and it's going to look like this. It's going to look like that. Instead of this length here being 2 pi, this length is pi because of this 2. So this is just a rough drawing. Square root of 1 over 3 is somewhere here. They want the answer between 0 and pi. Here's 0, here's pi. This is the only world they want us to look at. We can rub out the rest of it. This is the only part of the world they want us to see. So the answer is the first answer and the second answer, or on the original drawing was this one and this one, the 2 we did. So looking at this will let you know which numbers you need to get. Sometimes they've moved it the other way and it's the minus 1 answer and the 1 answer. Or sometimes it's like the 5th and 6th answer on what you'd get here. Hope that's clear. It comes up quite regularly where they try and trick you on which answer to get. Anyway, the answer for this question is this number here and this one here. If I wasn't clear enough, which I don't think I was, I ramble a bit on these, ask me in the comments. Rewatch the video first, please. Try your best to do it yourself, but ask me in the comments if I wasn't clear. Ask me to clarify something. And if you see any mistakes, let me know in the comments as well. Thank you for watching. Have a great day. Question 8 is a vector question. They've given us 2 points, A and B. They gave us the points as 2i plus 4k. I've chosen to write that in the column vector way. It's just easier to write, I find. So that's 2i, 0 j's, because there was no j's there, and 4k's. And the second point was 5, 1, and 6. Okay, with these 2 points, they tell us that a line passes through them. So let's draw like point A and point B. A line passes through them like that. They would like the equation of that line. Now, just to remind you how to do it, we have a 0 point, a origin here. This vector they've given us is the vector between 0 and A. And this vector is between 0 and B. So an equation of a line in vector geometry is a description on how to get anywhere on that line. And how I think of it, at least, is we start at 0 and we just need to get to somewhere on the line. So that gives you a choice. You can use the vector 0a, as I'm going to, or 0b. So we'll call this line or, and I was going to start off by going from 0 to A. That gets me onto the line. Now we want this to be everywhere on the line. So once I'm at A, how do I get everywhere else? I can get to say B by going plus AB. So that can get me, I could get to A and then to B doing this. If I just add in one variable, lambda, or you can call it any letter you want really, it's standard we use lambda. This can get me everywhere if I just change this number. For example, if I put 0 in here, I would end up at A. I would just go 0 to A. If I put 1 in, I would go 0 to A, then A to B. I would end up at B. If I put a half in, I'd end up here. If I put minus a half, I'd end up there. That's how we get the equation of a line. I just need to fill these in, I guess. So OR is equal, I need to do a little more than fill them in. I need to find AB first, don't I? Let me do that over here. I'll do it slowly again. AB is equal, we need to get from A to B. Well, I just go via the origin. A to O plus O to B, or as I'm sure you guys remember, it's just B or OB minus A or OA. That's how we get AB. So this AB is equal B minus A, which is 5 minus 2, which is 3. 1 minus 0 is 1. 6 minus 4 is 2. That's the AB vector. So this is A, B. So the answer to part A is just this 2, 0, 4 plus lambda 3, 1, 2. Of course, you could do this by using your I, J, and K as well. Same, it's just a little quicker to write this way. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. In part B, they give us a second line with another equation. I'll write it down here. And that is 215, so 215 plus some other, instead of lambda that's being used, so we'll use mu. But again, any letter there is fine. And it's a 1, 2, 3. 1, 2, 3 is the directional vector. These are two different lines. They ask us to show that they do not intersect. How do we do that? It's pretty much the same way we show they do intersect, or I guess it's the same way as we solve these. If we just put these equal to each other, that's how we find the point of intersection. Now, if we put these equal to each other, in this case, we're going to find a problem. And finding that problem means they don't intersect. Hopefully, it'll be quite clear what I mean here. First of all, we can add these together. Like this is just 2, lambda just multiplies everything in here. So this one, I call this first one L1. L1. This just becomes 2 plus 3 lambda. That's all the I parts. The 2 here and 3 lambda. The J parts are 0 plus 1 lambda. So that's just lambda. The K parts are 4 plus 2 lambda. That's one vector. And that's going to equal the L2 line. That's going to equal 2 plus mu. That's 2 plus 1 times mu. 1 plus 2 times mu. And 5 plus 3 times mu. 5 plus 3 times mu. These vectors equal each other at the point of intersection if it exists. That means the I parts, or I might sometimes say X, Y, and Z instead of I, J, and K, that's fine. The I parts equal the I parts, the J's equal the J's, and so on. Let me write all 3 of them down. 2 plus 3, lambda is equal 2 plus mu, lambda is equal 1 plus 2 mu, and 4 plus 2 lambda is equal 5 plus 3 mu. We've 3 equations and 2 unknowns. Not only can we solve this, we can oversolve it. And that's where a problem becomes. If sometimes they don't tell you if it intersects or not. They say find out if it intersects, and if it does, find the point of intersection. Some students are lazy, they take two of these equations and solve it. And if we do that now, we'll find an answer and we'll confidently tell people, look, they intersect, here's the point. What we're going to do is we're going to take two of these and solve it. Then we're going to take a different two and solve it. And if they don't agree, something went wrong. So that's quite easy to do in this case because this middle one is pretty straightforward. It's lambda equals. So I'm going to write this first line again, but instead of 3 lambda, I'm going to write 3 times this. So that's 3 times 1 plus 3 times 2 mu, 6 mu. But I'm still writing the first line is equal 2 plus mu. That's rearrange this, we get 5 mu is equal, let's see, 3. And that means mu is equal 3 over 5. I haven't left much room, but I'll squeeze in the next part here. Now I'm going to put this line into this one and see if I get the same answer for mu. If I get the same answer, they intersect, and you could use this number, put it back in up here and find that point. But if they don't agree, which is what we're going to find now, something went wrong. Okay, put it into this line. I get 4 plus 2 lambdas. That's 2 plus 4 mu. Oh, that's a y. Is equal 5 plus 3 mu. Rearrange this. I get mu is equal to 5 take away 6 and minus 1. So they do not agree. Oh, just checked my notes. This shouldn't be a 3 over 5. It should be minus 3 over 5. Yeah, 2 came over, cancelled, 3 came over, became a minus. Okay, so that's the answer to part B. They don't intersect because these don't agree. Minus 1 does not equal minus 3 over 5. Something's gone wrong here, and what's gone wrong is the assumption that these 3 all agreed. They don't all agree because they don't intersect. They don't equal each other because they can't equal each other because they don't intersect. In part C, they were still talking about these two lines, L1 and L2, and they ask us to find the acute angle between their directions. So if you think of these two lines, we already found out they don't intersect. So imagine my 4 arms are the lines. So they don't intersect each other, but they still have a direction. And if we just move those directions so they do touch, we can find an angle between them, an acute angle or an obtuse angle. Once we find the angle, we can just check if it's acute or not. So how do we do that? First of all, the direction. Everything about the direction of this line AB, this L1 here, could be told by this vector AB. So just this part here, yeah, this was the first one, wasn't it? Just this part, 3, 1, 2. That tells us everything about the direction of this line. The same with the second one. Who cares about this? That's just how you get from 0 to onto the line. This tells me everything about the direction. So let me write those two again. 3, 1, 2 is the direction of one of the lines. 1, 2, 3 is the direction of the other. Okay, so you have these two directional vectors. How do you find an acute angle between them? We do that with the dot product or the scalar product. We can multiply these together with this dot product, and we know the answer is equal to this first one. Let me name these U and V or something like that. The first one, the absolute value of it, or the length of it to 0, multiplied by the second one, V. I'll just say the absolute value of it, times cosine of the angle between it. So we just fill all these numbers in and solve for theta. Before I do that, I'll just do a lot of things separately. I'll do the dot product. This U times V, U dot V. Well, that's just how we do the dot product. It's just the i's times the i's, the j's by the j's, the k's by the k's. 3 times 1 is 3, plus 1 times 2 is 2, plus 2 times 3 is 6. Add all them up and we get 11. The dot product's equal to 11. How do we get the length? Remember, I just made up U. You can write the numbers every time if you want. The length here, well, that's just all of these numbers squared. That's 3 squared, 9. 1 squared is 1. 2 squared is 4. And the square root of all of them. So that's 10, that's square root of 14. V is similar, it's 1 plus 4 plus 9, it's actually the same numbers again, square root of 14. So to put all this out again, this equation up here, we get 11 is equal square root of 14 times square root of 14 times cosine theta. Square root of 14 by square root of 14 is just 14. So to rearrange this, we would get theta is equal to the inverse cosine. 11 would be over here and it would be divided by 14. And we put all that into a calculator and we get, I have two answers here. Yeah, I don't think they asked you, they didn't tell you to use degrees or radians. So I have both the answers here. In radians, it'd be 0.667, 3 decimal places they want. And when you're dealing with degrees, they want 1 decimal place, which would be 38.2. So there, either of those answers are fine. And that's it for question 8. If you have any follow-up questions, let me know in the comments. I'll do my best to get back to you. Thanks for watching. Have a great day. In question 9, they give us this integration, this equation with integral in it. And they then, out of nowhere seemingly, they ask us to show that A is equal all of this. I'm guessing a lot of students didn't know where to begin with this. They got thrown off by this equation over here. I've left it off to the side because that's what I want you to think of it. If this ever happens to you in the exam, I go, where did that come from? How do I do that? Try to ignore it for a minute and go back to the thing you do understand. You should have done questions like this. You should have studied integrations, integrals, and you hopefully know how to start this question. Then I want you to hope at some stage after doing this or in the middle of doing it, this appears. Okay, so that's what we're going to do in this question. We're going to ignore that and we're going to start off over here. With that said, this is still a hard question. I think a lot of students would still find a lot of difficulties with this. We have an integral with 2 terms, so this 6x and this natural log of x. That can be difficult to most people. There's a few choices when you have things like this. First of all, we think, can we do something fancy with algebra, or especially in trigonometry you often can. Can we rearrange things so maybe these just cancel and we're left with 1 term? No, not that I can see of. Next thing, which I think students might have got hopeful for, is can we do any substitution here? And on that front, a student probably very tempted to say, well, we can differentiate natural log of x and that becomes 1 over x. And surely 1 over x would cancel with this x. Very tempted to that. I won't write it out because it is wrong. Where you go wrong is, sure, the derivative of natural log is 1 over x, but you then have to divide that into the other term when we're doing substitution. And x divided by 1 over x just gets x squared, so you don't actually destroy anything. So what we're left with is we want to do substitution by parts. Have I wrote the formula down anywhere? I don't think so. So when we're dealt with 2 terms, like the integral of u times dv, we write it like this in most things. That will actually equal u times v minus the integral of v du. Basically, we can switch these terms around. How I like, there's lots of students have a list of ways to do this. I like to think it through, so I'm just going to show you my way. I write down u, v, du, and dv. We'll think of this as the derivative. There's a du dx if you'd rather here. This is just a way to help you remember. It doesn't have to be exactly maths what I'm writing here. So what I like to think is, I want to fill in the u term and the dv dx term with something from up here. Let me do the wrong one first. Which is the right one? Okay, let me do the wrong one first. Maybe if I put 6x here and natural log x here. That'd be one option, and we can differentiate this. This will become 6, that's fine. The problem is I can't integrate this to find out what v should be. And that's a problem. So we can't do that way. Let's hope the other way works out for us. So if we put natural log x here and 6x here, what happens? We can differentiate this, it becomes 1 over x. We can integrate this, it becomes x squared divided by 2. So this 6 divided by 2. So that's 3x squared. We get that. At this point, and often students do a lot of this just by scribbling it out or even thinking in their head. At this point, I want you to think, instead of these two, would these two be better? So, like, for example, that dx comes up here. So if it was 3x squared multiplied by 1x, 1 over x, that would be better because they just combine with each other. They turn into one term. So instead of this term up here, we would be left with, let's see, u times v, that's, I'll write v times u, 3x squared natural log x minus the integral, instead of u and dv, it'd be v and du. So that's 3x squared 1 over x dx. Nothing's changed with these units. This is still a and 1. But look, this x cancels in with one of those x's. So we're just left with, oh, this is also a unit between a and 1. This is getting evaluated between those. Let me clean all that up. We get 3x squared natural log x minus the integral of just 3x dx. This we can do. In fact, I'm running out of room, so I'll just do it right here. The integral of 3x just becomes x squared, the 3 is left alone, divided by 2. All of this is still evaluated between a and 1. Let me just go a bit backwards here to write the answer up here then. Apologies, that's very messy, but when I'm doing integration by parts, I take up loads of room because I just try out these ideas, so apologies, this isn't the most neat way to do it. It's the way I think of it though. Okay, we're filling a into this. We would get 3a squared natural log a minus 3 over 2 a squared. Then we take away this minus filling 1 in. That's 3 times 1, natural log 1, that's going to be 0. Minus, that's a plus, 3 over 2, 1 squared. Okay, this all just goes to 0. That natural log of 1 is 0. So we're left with this term here, and remember they told us it equals 4. Okay, this is the point where you might stop and go, okay, has this helped me get to this? What I'll do is I'm going to rub everything off. I'm going to write this equation again. I'll take this bit out. This equals 4. In fact, we'll move this over. So what's that? 8 over 2 minus 3 becomes 5 over 2. I'll leave the 5 over 2 in. I'll write this again and we'll show you how we can get from here to what they were looking for. The next step I don't think is all that obvious. How do we get from this to this? First thing I would suggest doing is taking the a squared and taking that term out. So we'd have a squared in two of these. That'd be 3 natural log a minus 3 over 2 is equal 5 over 2. The leap you want to take here that will help you solve this question. A lot of students might try and get a squared equals. So move that over, there'd be a big square root would appear. But what you want to think here is there's no square root in this. And in fact, there's actually an a squared inside this equation. So it's a different a. It's this a here we want to get on its own. And the other clue for that is, how would we get rid of natural log? We do that by having exponential appear. This is just e. Everything else is to the power of it. So we get rid of the natural log by an e. And that's where this appears from. So what I want you to, and I think students will be able to do it if they make this leap, get this term, this a here on its own. That's how this appears. So let's just go ahead and do that. We'll move the a squared over. We'll have 3 natural log a minus 3 over 2 is equal 5 over 2 a squared. Let's do some of this quickly. Minus 3 over 2 can come over to a plus 3 over 2 over here. We'll divide everyone by 3. Well, now let's do that a little one more line. Dividing everyone by 3, we'll get 5 over 6 a squared plus 3 over 6. Yeah, I'll leave that because it probably helps. No, I won't actually, because a lot of students won't have had that and they might be confused by the next bit. But it would have helped to leave that there, by the way. Okay, let's get the exponential of both sides. That gets a is equal, you could write e to the, I'll write e to the power first, but this is the same as writing exponential. 5 over 6 a squared plus 1 over 2. That's not identical to this. So what makes it different? First of all, let's change the e. That's not important. You wouldn't lose marks for that. You might lose marks for not finding where this 1 over 6 comes from. It can come out this term and it would leave 5 over a squared. Exactly what they have here. But it can also come out of 1 over 2. It comes out of it 3 times. How many times does 1 over 6 go into a half? 3 times. And I think it was more obvious when I had 3 over 6 there. Let's see, just close the brackets and boom, we're finished. That's how you do question 9 part A. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. This question has a part B and a part C, but part A was very difficult. I think a lot of students might have failed to do part A. I want you to remember that even if you fail to do part A, you can do B and C. They gave you everything you need here to do B and C. That's a very common thing to do. They don't ask you to find this, they ask you to verify it. And that's because they wanted you to have this. Okay, so in part B they ask you to verify that A is between 2 and 2.1. We do that just by putting a 2 in for A here. So I'll just put it, I'll just do that here. This is the exponential of 1 over 6, 5 over, if I put 2 in, 2 squared is 4, plus 3. And you can put all this into a calculator, or you could do a bit of it in your head. This is 12 over 4, 17 over 4, 17 over 4 times 6 is 24. You need to put that into a calculator. And I get 2.0306. So the left side should have been equal to 2. Put 2 in here. I should have got 2 is equal to. I didn't. It was too high. Okay, let's try it again. We'll put 2 equals the exponential of 1 over 6, 5 over 2.1 squared plus 3. Put all that into a calculator and you will get, let me do it here, you'll get 1.9916. That's enough to show that it lies between. You might want to add in some line that 2 was less than 2.03 when you put 2 in. In this case, 2 was bigger than 1 point this. So what we're really saying is when we tested one thing, so we have, we can think of this as 2 lines intersecting. This is a diagonal y equals x, or a, and this is something else. When we checked one point, one was above the other. When we checked the other point, the other was above the other. Which was above which, actually? Sorry. Yeah, my drawing's wrong here. So if this was the A, that's a diagonal line. This is above the other one. So when we checked, so 0.2 and a 2.1. When we checked here, this was above whatever. Sorry, no, it was below it. I'm sorry, it was below it here. And when we checked here, it was above it. The only way to get from there to there, I don't care what it looks like, it has to cross somewhere between there. So the answer must be somewhere between there. You don't have to say all that. This is bigger than this is less than this, therefore the answer must be between it. That's enough. there is no excuse not to be able to do part C because it comes up every year. It's a guarantee. In this case, it's only 3 marks. It's usually 4 or 5 for doing the previous bits. It's guaranteed, so learn how to do this. I'll do it again just in case. I'm going to write this, well no, I'll just change this equation to a of n plus 1 and a of n. That's the only thing that changes here. If you want the next guess, so what we're going to do is we're going to guess an answer. And when we guess the answer, we're going to put it in here. And we're going to get the next better guess out here. That's what the iterative formula does. Our first guess, I'm going to call A0. You can call it A1, that's fine. You can make this up. Whatever guess you want should work. Although we know from the previous part, the answer is between 2 and 2.1. So I would suggest most people would guess 2.05. But honestly, pretty much any number you want will work here. But you might lose a mark for not guessing a number between 2 and 2.5 because they set it up to be like that. Okay, so that's your first guess. Your second guess, A1, is just equal to this. The exponential of 1 over 6, 5 over A0 in this case. Your previous guess, plus 3. Yeah, that's it. So instead of A0, I guess we could just write 2.05. Sorry, that should be squared. Yeah, there is a square there. Put all that into your calculator and you'll get a number out. You'll get 2.0103. They want 4 decimal places. That's important. Every one of your guesses here should have 4 decimal places. But also, you should write 2 decimal places. So underneath it, you won't lose a mark for not doing this bit. But underneath it, you should probably put 2 decimal places because the final answer they want with 2 decimal places. And we're going to do this every time until this 2 decimal place answer agrees with a previous one. Then we know we're close enough. You could stay doing this. You put this into the next one, A2. Do the same thing again. You put 2.0103, or you save it from your calculator even. Put it in, get your next guess, get your next guess, get your next guess. I think you have to do it 4, maybe 5 times. Do I have a... Yeah, you have to do it out 4 total times. So not too bad. The exam will always work out to be, I'd say, between 3 and 5 times. Although there is a nice way to put this into your calculator. Learn how to use your calculator. I think I can explain it on the board, but every calculator is different, unfortunately. So what I do is I put in 2.05 into my calculator, I press equals, and what that does is this saves this as the previous answer. Then on my calculator, I put this whole equation in. I'm really careful. I put in exponential, I open a bracket up. I open extra brackets. I put 1 over 6 probably in its own little bracket. I then put open another bracket. I put 5 over, this is in its own bracket, over, but instead of the number here I put answer on the calculator. There's a button on your calculator that says answer, and I squared that. Maybe I put that in a bracket even. Put as many brackets as you want. Just be careful putting this in. Close another bracket. Close another bracket? Yeah, I think that's enough brackets. If you put all that into your calculator, the calculator remembers the previous answer to be 2.05. When you press equals, you'll get this number out. But here's the magic. Your calculator now remembers this as your previous answer. And it remembers this as the current equation in it. So if you press equals one more time, you'll get the next one out, which is 2.0263. 2 decimal places is 2.03. They don't agree, so we have to stay going. All you have to do is press equals on your calculator again, if you do it that way. You don't have to. So if you do it a long way or short way, you should get 2.01197. 2 decimal places, that's 02. They don't agree, so you have to stay going. A4 is equal 2.0224. They want to see 4 decimal places to know you're doing it right. To 2 decimal places is 2.02. They agree. So this is close enough as an answer. 2.02 is a good enough answer for them. A good advantage of doing it on your calculator like this, you can just press equals 10 times until your calculator stops changing even. If you were interested in the perfect answer, I don't know where, like maybe probably 120 or something. A20 comes out as 2.021622862. This is accurate to however many decimals that is, 9 decimal places. Not that you need that. Okay, that's it for question 9. If you have any follow-up questions, that was probably the hardest question in the whole paper. So if you have any follow-up questions or you've seen any mistake I made, let me know in the comments. I'll do my best to get back to you. Do me a favour and tell me where in the question you're talking about, because it's a pretty long question. Thanks for watching. Have a great day. In question 10, we're given this polynomial and we're asked to divide it by this polynomial and to find the quotient and the remainder. That's good information. We know there's going to be a remainder now. It doesn't go in evenly, so this is not a factor. There is a remainder. So how do we do that? We just do long division. We put this term over here with one exception. Let me write x squared minus 3. You don't have to do this. You can keep it straight in your head. But this is what I do, and what I advise students to do is make sure every term is there. The x squared term, the x term, the no x term. The x cubed term, the x squared term, the x term, the no x term. There's one missing. This is the x term here is missing. Put in 0x, whether it's on this part or this part. Put it in. It will help go through the whole thing. Okay, so we just have to look at the first term, the leading term on this, and the leading term on this. How much does how does this divided by this one? What would you get? Or what do you need to multiply this by to get this? And the answer is just x. So to multiply x by all of this, we get x cubed, as we knew we should. X by 0 is just 0, but let's write it in. 0x squared minus 3x. This keeps them all neat in line. Take them away. This minus that, it's gone. As it should be. 5 minus this, we just get 5x squared. Minus 2 minus 3. So that's minus 2 plus 3. So that's plus x we get. And then take the next term down. There's 3 terms here. We want 3 terms here. Okay, what do you need to multiply x squared by to get 5x squared? The answer is 5. So multiply it out. 5x squared. That's 5 by that. 5 by 0 is 0x's. 5 times minus 3 is minus 15. Very tempted to say, oh, it goes in evenly. It doesn't. That takes away that. X minus 0, we're left with x minus 15 minus 15. That does go. The remainder x. The answer to the question is the quotient is x plus 5 and the remainder is x. And another way to write all that information is, which is going to be useful in the next part, is this divided by this. I won't write it out again, too many things, but this divided by that is equal to x plus 5 plus the remainder divided by this guy, x squared minus 3. I won't bother putting the 0 plus x anywhere else. If you're unsure about that bit, just think of some simple thing like 8 divided by 3. That goes in 2 times plus 2 remainder. So plus 2 divided by 3. Same thing here. Goes in x plus 5 times x remainder. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. Okay, in part B, they want us to solve a differential equation. So that's here, dy dx, and inside this there's y's and there's x's. That makes it really difficult. This is one of the most difficult questions in at least college level maths, solving differential equations. The good news is, so don't panic too much, the good news is for A level we make sure to give them nice and simple questions that can be done with a nice method. Move all the y's with the dy, all the x's with the dx, and you should be able to solve it. If you try that here, you're gonna end up with a problem. You're gonna end up with this big. Actually, I guess we can do it to start with. Let's move the 6y over here, 6y, and move the dx over here. Okay, you've done that. You can differentiate, you can integrate this. This is fine. You can't integrate this side. Well, you can. It's just really difficult to do. Unless we could simplify this down. And remember, the first part, that's what we've pretty much done. I spelt it out a bit more. We can rewrite all this as 6y dy, that's fine. Instead of this side, we can take the answer from before. When you divide this by this, the answer we get is x plus 5 plus a remainder of x divided by x squared minus 3 with dx. This is a bit more integratable. You can integrate this term, easy. Integrate this one, easy. It all just comes down, can we integrate this term? So let's do that. Let's take that off to the side somewhere. Let's integrate x divided by x squared minus 3 dx. Can we do this? Looks hard, but not too bad. It's actually just a substitution. We take the more complicated part and hope that when we differentiate that, it will cancel out this part. So that more complicated part, u is equal x squared minus 3. Differentiate that, we get du dx is equal 2x, just 2x. I like to, you don't always do it, but I like to rearrange it so it's because we want to replace this dx. So we rearrange dx up here, 2x down there. We write it as dx is equal 1 over 2x du. Okay, let's replace everything with these new substitutions. This integral I will become, let's see, we'll leave x alone. This x squared minus 3, well that's the same as u, so we'll put a u in there. dx, we'll put in 1 over 2x du. This x cancels with that, and we're just left with the 1 over 2 can come out, the integral of 1 over u du. That is doable. That's actually just the 1 over 2 is left alone, natural log of u. Or, let me do one more line. 1 over 2 natural log of, instead of u, we're putting in x squared minus 3. So we can integrate that. So let's integrate everything now that we've done the hard work over there. So the integral is 6y. Y becomes y squared. Divided by 2, so the 6 gets divided by 2 is a 3. X becomes x squared divided by 2, which, we'll just divide that by 2. Just divided by 2. The 5 becomes 5x, and as we just did over here, this becomes 1 over 2 natural log of x squared minus 3. And they all have constants. So we can just put all those constants together, like a constant plus a constant plus a constant just equals a different constant. We don't really care about the names of them. I'm just going to call them C. And that's it. We're pretty much done, except they asked us to obtain an expression for y squared in terms of x. Well, there's y squared. There's no other y's. We just divide everything by 3. I'll just rub this 3 out. That becomes a 6. That becomes 5 over 3. That becomes a 6. And I guess c becomes c over 3. But really, it's just a new constant if you want. You can change letters each time, like c1, 2, 3, 4, 5. I'll just call it c. No big deal there. Now we're done. Oh, not quite. We're going to lose a mark for this. Maybe even 2 marks. Because what's c? They didn't say there could be a constant in it. And they gave us enough information to get rid of c. They told us that when x is 2, y is 2. All they had to do is tell us any 2 numbers for x and y. Because x and y change. Any given time they change. But c is always c. So if you find out what c is when x is 2 and y is 2, you find out c all the time. So we can put it in the general equation. So let's just fill them all in. The 2, y equals 2 and x equals 2. This becomes 4. This becomes 4 over 6. This becomes 10 over 3. This becomes 1 over 6 times natural log of 4 minus 3. that's 1, and that's going to go to 0, plus c. We can multiply everything by 4. I'm a little out, sorry, by 6 to get rid of these 6's. I'm a little out of room, so I'll just put that in there. 24, that'll become 20. That's nothing. This, multiply this by 6. We could just leave it as another c, but alright, let's put in a 6 here. Rearrange it, so we get 24. 4 plus 20 is 24. 24 equals 24 plus 6 c's. The c must be 0. It can't be adding. 24 equals 24. So this here must be 0. So c equals 0. I think you'd get full marks for writing that. But I'm guessing they would want you to write one more line. I don't really have room for it, so I'm going to put it in up here. That line is this line. Y squared equals x squared over 6 plus 5 over 3x plus 1 over 6 natural log x squared minus 3 without the c. Oh, sorry, they definitely want this down here because this looks like you just forgot the c up here. They probably want you to write this line one last time at the very end. This is the very end. They want you to write that. Okay, I hope that was clear. I apologize. I'm not very good at organising my board. I need more boards. I need like 5 or 6 of them. One of those that scroll up and down. Right, that's it for question 10. If you have any follow-up questions or you see any mistakes I made, let me know in the comments. Do me a favour, tell me where in the question it is and I'll do my best to get back to you. Thanks for watching. Have a great day. In question 11, we're given this equation here. Y is equal cosine of x multiplied by the square root of sine of 2x. And we're given this drawing representing this function. They've highlighted a point here, m, and they tell us this is the maximum point. They want you to find what is a. When x equals a, what is a? You're going to get a few marks just for writing this. You're going to get 1 mark, I'm sure, just for writing this. dy dx equals 0. Because maximum, that's what we're looking for. So what we're trying to do is we're trying to differentiate this here. We can do that. That's not too bad. It's 2 things multiplying each other. So yeah, let me just go ahead and do that up here. dy dx is equal. We're going to use the products rule. You can be careful and write it out. It's a long question, so I'll just do it a little faster. I'm going to leave the first term alone. I'm going to write just cosine x. Then I'm going to differentiate the second term. So first of all, let's take out the square root and put in to the power of a half. The derivative of this is a half multiplied by sine x. We're using chain rule. We're actually going to use the chain rule twice here. Chain rule inside itself by sine x, and this is now to the power of minus. But what was in this bracket wasn't just a simple x, it was sine 2x. So we better differentiate that and multiply it by. The derivative of sine is cosine, and again we'll just leave 2x, but the problem again is this 2x, that's not simple. And we better differentiate that and multiply by it. That's what the chain rule does each time. So we end up multiplying by 2. I'll put that 2 here just to keep it safe. So what we've done is we've left this alone and differentiate this. Then the product rule tells us to add the derivative of the first one. Differentiate this is minus sine x, that's simple. And we leave the other one alone. That's sine 2x to the power of a half. I can clean a lot of this up. Well, I can clean some of it up and rewrite it different ways. But remember, we know this all equals 0. Okay, we'll write cosine x. This becomes 1. We'll put this on the bottom row as, I'll leave it as to the power of a half though. You can write square root, that's fine. We have cosine 2x up here. Let's move this across the equals. So this will become plus sine x times sine 2x, or the square root of that. Okay, we get this term here. That's dy dx. We're going to get marks for that. We still need to solve for a. But look, we have an equation with just one unknown. There's x in here. This should be solvable if we're able to do it. And there's lots of tricks we can do to help us with that. For example, I'm seeing cosine 2x and sine 2x. Remember from our formulas, we have a formula for when cosine equals 2x. It's cosine 2x is equal to cosine squared. Let me write them over. No, I'll just write them in as I go. So cosine x, I'll leave it on. Cosine 2x is cosine squared x, minus, that'd be just 1 otherwise, minus sine squared x. That's replacing cosine 2x divided by sine. We could replace this 2x, but let's save a few moments if I do it over here. Oh, I've changed back to square root. Whatever, that's fine. This is equal sine x, because hopefully, maybe you noticed up here, this is sine 2x, square root of sine 2x as well. Multiply both sides by this. This just comes over here, multiplies by this, and basically the square root just disappears. It shouldn't be a minus there, this should be just multiplied. Okay, so let's replace this sine 2x. Let me do it over here. Sine 2x becomes 2 sine x cosine x. Okay, we got rid of all the 2 signs. Everything's similar, very similar terms now. Let's just multiply these brackets out and just see what we get. Play around with it. We'll get cosine cubed x minus cosine x sine squared x is equal, let's see, 2 sine squared x times cosine x. Cosine sine squared, cosine sine squared, these are the same. There's minus 1 here, comes over plus 1. I'm saving lots of room here by cheating a bit, but move this across, we just get 3 of these guys. 3 of these guys. What else can we do? We can divide cosine by both sides. That goes into, there's 3 of these, now there's only 2 of them. Be a little careful there, I just divided by something. What if that was 0? Cosine x is 0 sometimes. So a lot of students might be like, how come I was allowed to do that? The reason I'm allowed to do it is I'm in this world right here. Cosine, we're somewhere between 0 and pi over 2 for x. So cosine of x isn't 0 at this point. If we were talking about this point, then yeah, I'd be in trouble, and that would just mess up. Dividing by that across would just mess up. So we're left with cosine squared, sine squared. You should be thinking you might be thinking cosine squared plus sine squared. Put that together. We just seen up here they can go together. Cosine squared minus sine squared. We could combine them like that. How I choose to combine them, I divide this by both sides and move the 3 over. So I'll be left with 1 over 3 is equal sine squared divided by cosine squared. Is just tan squared. Just solve for that. Square root of both sides, and we're left with x is equal the inverse tangent of 1 over 3 of the square root of 1 over 3 is just 30 degrees, or pi over 6, and that's the answer to part A. Apologies if I skipped a few bits there. I don't think I taught that too well. I'm sorry for that. But if you have any questions about that, let me know in the comments. Otherwise, I'll rub it out and we'll move on to part B. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. In part B, they talk about the region enclosed in the x-axis. So that's between 0 and pi over 2 here, this region here. And they talk about the idea of that being rotated around to make some sort of shape. Think of this as some blade, then you're going to cut out something, a bit of wood or something. You can imagine the sort of shape you'd get. That'd be quite interesting. What's the volume of that? Now this, hopefully you've learned this. I'll show you where it comes from now, but hopefully you can just write the formula down. If you can't, here's how I think about it. Let me draw just a whole new shape like this. What integration does is it cuts this up into little bars like this. Okay? And what they're talking about doing is rotating that around the x-axis. So let me take one of these bars here, just one of them. I'll make it This is infinitesimally small, but I'll just make it a little bigger. What would happen if we rotate that around? What kind of shape would we get? We'd get like a disc shape. How wide would it be? It'd be dx wide. That's how wide these are. They're the change in x. That's what the dx comes from. Delta x. The change in x. The radius of this thing would be the height of this. The height of this is just y. Y is the height of over here. So what's the volume of this? The area of a circle is pi r squared. So pi y squared in this case. And the volume of this disc would just multiply it by this dx. Dx. That's how we get the volume of this disc. And then to get the volume of the whole shape, we just add them all up. And that's actually what this integration is. That's why it looks like an S. It means sum. And we're adding it all up. And we add them all up between pi over 2 and 0. So that's how. Now, I expect most students just to write this formula down. Okay, so let's just write this out again, but instead of y squared, we'll put in the y squared we had from the first part, the y we had from the first part. Pi can be brought aside, it's just a constant. Y squared would be cosine squared x. The square root of sine 2x squared would just become sine 2x, and then we'd have dx. So we just need to integrate this. You'd be tempted to start thinking about substitution at this stage, or to start even doing integration by parts. There was already one of them in this paper, so that might give you a hint that that's not what we need to do here. But whenever you're dealing with trigonometry, there's very often tricky things we can do. It's very tempting to think you could do integration by substitution here. Take sine x, the integral, the derivative of that is cosine, cancels in. Maybe that's it, or maybe take cosine, cancel this. But we can't, because this is x and this is 2x. That's the job one we have to change. Let me put a line here. So let's change this. I'll write it all again. I'll save this till the end. We already learned what sine 2x becomes. That let me just remember. That becomes, sorry, cosine squared x. That becomes 2 sine x cosine x dx. We can combine a lot of this. This all becomes let's see, pi cosine cubed x. Sorry, 2. The 2 can come all the way out by sine x. Okay, so now we can start working on this. Now again, you'd be tempted to think integration by parts. There's two things. We don't have to go that difficult. Substitution. We are going to use substitution. Again, lots of students might say, well, I'll take sine x. I'll substitute that in, because the derivative of sine x is cosine x. And that'll divide in. Problem is, it will still leave 2 cosine x's multiplying. So that's not the case. The one we need to use is u is equal cosine x, because the derivative of that is minus sine x. So we can rearrange this so it's dx is equal 1 over, or minus 1 over sine x du. So if I replace this in, I'll bring it all the way down here. Yeah, we'll squeeze it in down here at the bottom, and then I'll clear off the board and start again. Pi, we'll change this. Yeah, it's a little s there. Integral, this will become, let's see. Oh, sorry, this one here I'm replacing with. Cosine cubed will become u cubed. Sine x will still be here, sine x. Dx will be replaced with a minus 1 over sine x and a du at the end. That's sine x and that's sine x destroy each other, and we're left with, which is what I'll do when I clean the board. I think there should be a 2 out here. Yes, 2 pi integral u cubed. Sorry, minus will appear as well. Du. We're left with this. I do not have the correct limits here. You could change these limits. I like to change these limits to a new set of limits here when I substitute u. What I think most students though like to do, so I'll do it, is they solve this first and then they change u back into cosine x. So let me clean off a lot of this board and we'll start again at this point. This integral isn't too bad, minus 2 pi left alone. The integral of u cubed, that becomes u to the power 4, and we're going to divide by 4. And that's it. We're going to evaluate this at some new sets of limits unless we change u back in. So let's do that up here. We'll write this again. This equals minus 2 pi. Instead of u, we'll put cosine back in. Cosine to the power of 4 divided by 4 this is. This, we have the limits for this. This is pi over 2 and 0. I want to stress, you can just use this. You don't have to change back to cosine. Just once you change your limits earlier, which isn't too bad, I guess cosine x or cosine pi over 2 is 0 and cosine 0 is 1. So your limits here would just be 1 and 0, or maybe 0 and minus 1. I haven't checked. That'd be perfectly fine to do. But I just think lots of students change it back in. Okay, so just put pi over 2 in. Cosine pi over 2 is 0. So that's going to save you a bit of work. You don't really have to put that in. Minus, this is 1 over 2 pi. Put 0 in and we get 1. So we get 1 to the power 4. That's just 1. That's just 1. We're left with the final answer, a half pi. Okay, that's it. That's the final answer to question 11. And that's the final question of the paper. If you have any questions about anything in this paper, in this question, any mistakes I made, let me know in the comments. I'll do my best to get back to you. Thanks for watching. Have a great day.